In this video, we will learn about variables and types. Variables store information, but it can't store any information. It has to store all of the same type. What is a type? We will get to that in just a second. I typed in C++ types on Google to help me out. You could see that I get a bunch of hits on variables and types. C++.com is a good resource. If I click on variables and types, I will come to this page. It's all good reading, but I want to come down here to fundamental data types. Now we could think of types as shoeboxes that we want to store our receipts in. Okay, so let's say I have all my receipts for my car. I want to put those in a separate shoebox of all my receipts for groceries. And then I want to have a different box for all my receipts for entertainment. So I don't put my entertainment receipts in my car receipts. I keep them separate, and they remain separate. It's the same thing with types. We have these fundamental data types. We have character types, integer types, floating point types, Boolean types, the void type, and a null pointer. I'm going to skip over character types right now. All these types consist of a variable in memory. So if we have an integer type, all we can store is whole numbers in that variable. Unlike a floating point type, we can store floating point numbers or decimals in that variable. A Boolean type, we can only store true or false. A void type is a special type, and we'll get to that later. Sometimes functions return nothing or void. We'll talk about null types later in this class. I have modified our Hello World program. If we open it, we can see I have int I equals 0. So I can only store in whole numbers in this, and there is a limitation. It is based on the size of our shoebox. A long int can store a larger number than an int. See, we have short int, long int. Those are all different sizes of the variable. In our case, ints will usually suffice. We can most likely use ints in all our programming, but we can only store in whole numbers in ints. So we have the type right here, the variable name right here, and in this case I'm initializing the variable to 0. So when we define a variable, we always start with type, followed by the variable name, followed by the initialization if we choose to initialize. So we can only store in ints in I. We can only store in floating point numbers in double. Okay, an example is 4.58. And notice I have a double. A is in lowercase, D is in uppercase. Okay, that's called camel case. Camel case is denoted by the first word is lowercase and every subsequent word is capitalized. So a double is a variable of type double. Okay, Boolean is denoted by bool, is prime. Okay, again it's camel case. Again I am initializing it to false. Boolean can only store a true or false. So all booleans can store. What I've declared here is prime equal false. Let's say I want to determine if a number is prime. Well, I'm going to assume it's false, that it is not prime, until I definitively find out if it's prime. So that is a Boolean variable. We also have strings. Here I've declared an error string as a string, and I've initialized it to you entered too many semicolons. So I might want to print out this error string to the user. You entered too many semicolons. One thing about variables, you always want to make a variable as a noun. Variables are nouns. As you can see, we have double, we have error string as a noun. All your bools will probably be something like this is prime. They're answering a question as in is prime, is adult, is student, is parent. But in the usual case, a variable is a noun. And in most cases, you want to make the variable something you could remember. I is not a real descriptive variable, but one thing in programming, I, j, and k are accepted as integers. Normally you would want to say counter or number or amount in your variable. You usually don't want single character variables. Anyway, that concludes this video on variables and types.